Hi friends, welcome to the channel Learning R is Fun. In our last video, we have installed R and RStudio IDE. After that, we had a small tour in RStudio. In this video, we will see data types and built-in constants used in R. In the real world, we like to store information through various data types like character, numerals, logical values, etc. We will see fundamentally all types of data boils down to numeric or character types. In the digital world, we know even these are ultimately represented by zeros and ones, right? However, for the human understanding, programming languages support different data types. In R, 6 atomic data types are supported. Numeric data type is synonymous with double. Double precision numbers are shortly called as double. R has no single precision data type. All real numbers are stored in double precision format. Double precision means the numbers take twice the word length to store. On a 32-bit processor, the words are all 32 bits. So, doubles are 64 bits. Integers are to be represented by writing the integer immediately following it with uppercase L. Characters can be individual characters or character strings representing words, sentences, names, and so on. Logical values are represented as true or false in uppercase or T and F abbreviations. There is another logical value NA which represents missing values in R. We'll see what is NA in another video later in this series. Raw and complex atomic data types are infrequent in this course and we don't deal with them for now. Using these atomic data types, more basic data types are created such as vectors, lists, matrices, arrays, and data frames. These are called data objects in R. Vectors are the most basic R data objects, or simply objects, and there are 6 types. In other words, you can create vectors consisting wholly of logical, integer, double, complex, character, and raw values, but only one of them in each vector. Even when you write just one value in R, it becomes a vector of length 1 and belongs to one of these vector types. We use variables and constants as fundamental units to develop a program. Almost all programming languages provide the feature to make use of variables and constants. Data is stored in named containers. You can think of these as variable names. In other words, variable is like a container in the memory. Obviously, you have to name the container to enable you to locate it. In the container, you can place data of any type. When we create a variable or reserve some space in memory, say a container, the size of which is changed as per our need. When we assign a value or values to the variable, R creates objects with the variable name as object name. Good variable names can reduce the need for comments, but long names can make complex expressions difficult to read. So there is a trade-off. There are some rules for writing identifiers, that is names of variables, but you don't worry about them. You will be prompted when you give an illegal name. a.variable.name is preferred over a_variable_name. Or alternatively, we could use camel case as a variable name with V and N as uppercase. Before we go to RStudio, let me give a brief explanation of these words. Elementary commands consist of either expressions or assignments. Expression is anything which R can evaluate. Statements are those that can be executed. Assignments are those which assign value to a variable. Objects are those R creates when we assign values to variables. A small session in R would make things clear. In R, we save scripts in files with extension .r. I have loaded one such file, atomic data types and built-in constants.r in RStudio IDE to save time. Let us look at the first line in the script, which is at line 3. I have left lines 1 and 2 blank, and R ignores blank lines. Comments start with a hash symbol indicating what follows the symbol is a comment, and R need not worry about it. Comments can come in handy when you don't understand your own code at a later time. Comments can be put almost anywhere, starting with a hash mark. Everything to the end of the line is a comment. OR has a very simple syntax. Syntax is a set of rules for grammar and spelling. OR takes a number appearing by itself as a statement and also stores that as a vector of length 1. We transfer the statement from script to console using Ctrl plus Enter in Windows platform. We will transfer our first statement, which is a simple number, just 6, from editor pane to console pane using Ctrl plus Enter. Console immediately executes it and the result is shown as 1 in square bracket followed by 6. OR tells us that it has just read a vector of numeric and the index of the first value 6 is 1 in that vector. But here the value and the vector is not stored and OR forgets this immediately forever. If an expression is given as a command, it is evaluated, printed, and the value is lost. Let us see 2934 plus 6421.94. This expression, let us transfer. We get the sum, but we don't get it stored anywhere. An assignment also evaluates an expression and passes the value to a variable. Less than symbol followed by a hyphen is the assignment symbol, no space between these two characters. Let us now assign this sum to total. Let us execute this. Total object is now created, which you can see in the environment, but nothing is shown in the console. Next prompt is automatically coming. But if we give within parenthesis, that is the next statement, then OR will also print it in the console. We'll see that. To establish that OR is case sensitive, let us create a vector named profit. Profit, let us assign 14. This statement will execute and profit object is created. We can see in the environment. If you ask OR what is profit with uppercase P, it will say no such object. Commands are separated either by semicolon or by a new line. Let us make multiple assignments in the same line using semicolon first. So we are now giving A, B, C, 3 variables, values 1, 2 and 3 in the same line with the semicolon as the separator. All 3 objects are created. For making assignments, we can use equal sign or reverse assignment process also, which are shown in the next 2 statements. But these methods are not recommended. In all 3 cases, OR creates 3 objects as we can see in the environment. Elementary commands can be grouped together into one compound expression by curly braces. Let us make 3 statements, basically assignments under the curly braces. Principal is assigned with 10,000, interest number 10 and years 5. When we transfer these statements to the console, OR shows plus symbol before each line. That is the way of OR's expression that I am waiting for further commands. That is the last curly brace to complete this compound statement. Once that is obtained, all 3 lines are executed. Now let us see how to assign more than one value to a variable. We will use concatenation function denoted by lowercase c and assign a set of values to the variable named x. Note the lowercase c. Uppercase c means another function totally different. The statement assigns a set of values 10.4, 5.6 etc. to x. We can see x in the environment when we execute this as a numeric vector. Now let us quickly rush through atomic data types. Before that, we will get to know a function type of. This function will tell us what type of object we are dealing with. Type of function determines the OR internal type or storage mode of any object. Let us execute these 4 statements, double var 1, double var 2 type of both these variables. We can see that OR shows the type of double var 1 and 2 as double. Similarly, we can create integer vectors using uppercase L after the integer. Let us now create a logic vector, logic var, concatenation function and logical values. Now logic var object is created as can be seen in the environment pane. NA represents a missing value and treated as a logical value. Internally R treats true as 1 and false as 0. This can be seen by the statement true plus true, which evaluates to true. On similar lines, we can explore complex data types. I have created 2 examples, and the type of function also reveals that they are complex data types. Whether it is single character or strings, R takes it as a character data type. Let us see this using these 2 statements, A and ABC. In both cases, we see it's a character vector. To store the raw data type, we use as.raw function. So raw variable assign as.raw 56 number. The result is hexa38. Hexa38 is basically 3 into 16 plus 8. You get 56. 38 is nothing but 38. It is not 38, it is 38 base 16. Now we have dealt with atomic data types. We can use is.dot function to verify a given object. Is numeric, is double, is integer, is raw, is complex. These functions help you to determine a given variable is of that particular type. You get yes or no. That is true or false. Now we will turn our attention to R's built-in constants. Letters in uppercase represents alphabets in English language from A to Z as uppercase. And type of letters we get a character vector. Similarly, letters in lowercase use lowercase alphabets. Pi is represented as Pi and E, base of natural log, is defined as exp of 1. All 12 months abbreviations are represented by months.abb constant. Similarly, you get full names of the months using month.name. Now we have come to the end of this session. In this session, we had seen 6 atomic data types in R, how to create vectors of different data type objects, how to find data type of an object using type of function or is.dot function. We also saw some built-in constants. In our next video, we will see more about vectors and how we can exploit the vectors. I hope you have followed along in this video. Go ahead and create vectors of all data types and experiment with the functions introduced in the session. Thanks for watching. See you in the next video.